Hello, in this video, let us learn how to solve this question. So we have t raised to power t is equal to 11, and here we have to solve for the value of t. T is the unknown we have to solve for. To solve this, solution, so we have t raised to power t is equal to 11. Now, the idea behind this question is that you will pick a particular number and raise that number to that same number, and the value must equal 11. So let's say, for instance, we test it out. Let's try to test. Now, if you try 1 raised to power 1, this will give us 1, and it is not equal to 11. If you try 2 raised to the same 2, this will give us 4, and it's not equal to 11. Now, if you go ahead to try 3 raised to power 3, this is equal to 27, and is not obviously equal to 11. But then looking at it, number 11 is in between 4 and 27. That is, it's in between 2 and 3. So 2 and 3, that is where the number 11 is. But then, to find the exact number that will give us 11, the number will be in between 2 and 3. That is a decimal number, something in the form of 2.1, 2.2, 2.3, thereabout. Now, we don't know the exact number that will give us 11. Now, instead of us to go about the stress of testing each and every number, there is a much more easier way to solve this. So here is how you can solve it. So the first thing we are going to do is to introduce natural logarithm to this equation. So ln t raised to power t is equal to ln 11. Now with this, we can then apply this rule of logarithm, that if you have logarithm of a raised to power b, this equals b times logarithm of a. And don't forget that logarithm is simply log to base 10, while ln is simply logarithm to base e, which means that we can apply the property of logarithm to natural logarithm. So applying this rule right here, this means that power t comes over to this side, then this becomes t times ln t. Following this rule is all equal to ln 11. So with this, the next thing we're going to do is to apply a particular function, and the function is this. We call it the Lambert W function. Okay, the Lambert W function. Now, this function works in this way. Suppose you have an expression like this, a times e raised to power a, and you want to solve this. Simply impute the Lambert W function to this. What you will get as the value equal a. Same thing also, let's say you have, let's say, a fish times e to the power of fish, and you apply the Lambert W function. What you will get is a fish, that same fish. So applying this function right to this, what you are going to do is to manipulate this expression to resemble something of this or of this. Now, to do so, what we are going to do is that we're going to introduce e. You see, if you have e raised to power ln x, right, this is equal to x. Why? Because if we cancel ln, x will stand alone. Same thing also, if you have e raised to power ln t, this is also equal to t. Why? Because if we cancel ln, t will stand alone. So we can say that t is equal to e raised to power ln t. So the t right here, this t right here, we can bring in e raised to power ln t, such that what we then have is, from here, we have e raised to power ln t. To replace this t, then times ln t, all is equal to ln 11. Now, at this junction, if you look at this expression, you'll notice that e is in the second place. So move this e to stay in the second place. So we have ln t times e raised to power ln t is equal to ln 11. Now, at this junction, as you can see, we have the same expression. We have ln t times e raised to power ln t, something like this format, a times e raised to power a. So ln t has the same power also ln t. So we can then apply the same lambda w function, that if you have w into bracket ln t times e raised to power ln t, okay, and also apply it also on the other side, so w times ln 11. So with this, once you apply the lambda w function to this, what you get is ln t, which equals, we have w times ln 11. So to then solve for the value of t right here, what we are going to do is to eliminate ln. And to do so, we are simply going to bring in e. So you will say e raised to power ln t is equal to e raised to power w times ln 11. And once you do so, what will happen is this: a will cancel ln, we have t is equal to e raised to power w times ln 11, and this is the final value for the solution of t. But then if you are wondering, okay, why is the value of t not in numerical form? Well, to get the value of t in numbers, simply press in your calculator, you press e, and sometimes you will not see w in your calculator. Instead, you will see product log. So type in power of product log, then multiplied by ln 11. And once you type in this in your calculator, what you will get as the value of t will equal 2.5557 in 4 decimal places. So this means that once you raise 2.5557 to 2.5557, you will get the value to approximately equal 11. The value of t that will satisfy this equation is 2.557. So with this, I hope you all enjoyed the video. Don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.